to introduce myself, I'm Ashley. I run the data engineering team at BuzzFeed. So most of the stuff you're going to see today, me or my team have built. And I've been working on data problems for a long time. My whole goal is to be able to give people the best information to make the best decisions they can. So yeah, with that, let's get into the heart. So I think it's important to understand a little bit about BuzzFeed. Some of you may or may not have heard of it. But basically, BuzzFeed is all about super fun content, but there's kind of like a heartwarming story in the middle of it. We're all about the share. So editors are looking to make content for our site and for other platforms that make a human connection. So this one's maybe like a little less relevant to me, but I might share this with a friend. Our whole idea is that if you can click on a piece of content, but if you share that piece of content, we've done our jobs and we've really made a connection with you. So maybe I share this with a friend. I'm like, oh, hey, do any of these appeal to you? Are these things true? And that piece of content helps us have a conversation. So all of the metrics that I'm talking about today go back to helping us make better connections with people. So on to our data infrastructure team. I love my team, and this is just a great hug. So I hope you guys will find the GIF game on point. I am repping BuzzFeed. So yeah, so we are a part of the infrastructure group. So that guides some of what you're going to see today. We see ourselves as sort of a base layer within BuzzFeed Tech. We're a pretty small team. There are only 5 of us supporting all of BuzzFeed's data infrastructure needs. And we're relatively new. BuzzFeed is older, I think, than a lot of people realize. It was founded in 2006. And they got really far without having any sort of dedicated engineers. But we came on the scene in 2014. So all of the infrastructure that you're seeing today has been built since then. And when we're talking about what we build, I think it's really important to understand why you build stuff, right? Datadog's talk earlier today is a very familiar architecture, but I think it's important we've solved a lot of technical problems by approaching it in a particular way. And what we've done is we said, we are building stuff that's at the base layer. We treat every product that we make as a product. So it's not just oh, hit this metric or build a Hadoop database. We're going to think about that as a product that's serving a need, that has stakeholders, and something that evolves and iterates. What we're also doing is we're optimizing for other teams' independence. So if you have to talk to me to get something done, I've missed something. Something isn't abstracted, something isn't easy enough. What we're trying to do is make it easy for some other team to build fast. So today we're going to go through a little journey through time and then have some takeaways. I think what I'm talking about today and some of the things that we've talked about optimizing apply to new organizations, large organizations, teams that have had a data engineering team for a long time, or ones that are new. So I'm kind of curious to understand where everyone's at. Who's at a large enterprise company? Cool. Who's at a startup that's maybe a couple of years old? Okay, a lot of people. And for those startups, who's at one under 50 people? Okay, cool. So what I'm talking about works at BuzzFeed scale, but this is a pattern of development that that works regardless of your stage of development. And I hope at the end of this talk you come away with stuff that you can do on your day-to-day to make both you and the teams you work with, including data scientists, a little bit happier. So let's start our journey. It's a little bit in 2014. This is before BuzzFeed has a data engineering team. Is a bit of a Wild West. You've got one big tech stack, one big tech team. And data scientists are doing a lot of work, but God love them, they have to work really hard to make it happen. There's lots of unchecked code. They have their own servers. They are, like, anytime you want a new stat or a new report, it's a lot of work. So this is, like, not a great situation. On the data collection side, those scripts are, like, data is really kind of hard to access. There's a couple of databases, there's permissions around that. Collection is both slow and latent. So, like, it's 15 minutes at best for you to get data. And those things are not particularly stable, so they fail fairly often. And when they fail, it's hard. There's, like, no one there to fix it. Teams are, like, highly dependent on a couple of engineers to fix stuff. It makes this sort of, like, slower. Like, on the tech side, BuzzFeed as a company is moving very quickly at this point. This is at the time where BuzzFeed traffic is exploding. It's growing really fast. Like, BuzzFeed was for a long time pretty small, and now at this time that data engineering comes on the scene, it's somewhere around 150 million uniques a month, and BuzzFeed is growing, like, doubling in size, approaching the, like, triple-digit headcount number. So as engineers, we come and we say, what do we build first, right? Like, there's a lot of opportunity, I think is the nice way to phrase it, right? We could maybe fix those collection scripts and patch what's existing. We could solve the problem in a different way and be like, hey, we're gonna keep the database the same, we're gonna keep collection the same, we're just gonna create a data warehouse over here that everyone can access. Or we can do none of that and maybe build some tools on top of it. So you don't have access to the server, but you can, like, get the data you need. We didn't do any of that. We built pipes because I think that is foundational to what we talk for everything that comes later. And this was our thesis. If we solve data collection, if you have a reliable way to capture data, everything can come later because you know how many clicks, you know how many shares you got. If it's not perfectly easy to access right now, we can build tooling around that. We can evolve, but you can't get back data you didn't collect. So that's the first thing we built. And having a good data collection enables us to make data available to other teams and let them do their jobs better. So now we've built some pipes. And with this data collection, our whole point is now going to make the impossible possible. What wasn't possible? Data access and data collection. So the way we chose to do that was with NSQ. NSQ is distributed, super easy to set up, message queues. My boss wrote it. It may or may not have influenced the choice. But yeah, so basically, this has a nice property in that it's both very easy to set up, but then it, like, adding new consumers is basically free. So we now have the ability to send new messages. So a producer basically sends a message to a topic, and that gets routed to every consumer who's subscribed to that topic. So basically, publish once, it's available everywhere. It also has a second property, so, like, the pub/sub stuff is the real-time component, but every message that gets sent is also archived into S3. So we seamlessly are creating our past while we're, like, consuming the present. So after that, so the first thing we built on top of that was just kind of a simple Python API, which is yet another tracking pixel. We called it pixie dust because it was a little magical at the time. And BuzzFeed.com at this point is our only producer. So we have a little tracking pixel. Now in real time, we know our traffic, where that traffic is coming from, clicks, shares, like, your basic tracking, right? Which brings us to like a super exciting time. Things that weren't possible before happen now. So you can do like dashboards. Who doesn't love a dashboard? If you have some data, visualize it, make it a dashboard. This is incredibly important for editors because like the early moments of a piece of content are very important to its success, right? Like you can see, this is something that was published, and then the first like hour or two, a successful piece of content goes up and to the right really fast, and a less successful piece of content just sort of stays flat. And we promote winners at BuzzFeed, so basically, if a piece of content is doing well, you can start to make decisions about, oh, people like this, let me share it out more broadly, and hopefully it does even better. We can do stuff like having trending, and we can split trending lots of different ways. We can trend by region, by author, by vertical, so like cat things. So like with a little bit of work, we've really opened up what's possible for the business and any other consumer of data, like our buddies, the data scientists. Here I want to highlight like one super important thing that has been really useful for like just made everything else we've built so much simpler. And we decided on a single source of truth. And that single source of truth is the archive of the messages that that come from that NSQ. So if you want to calculate a stat at BuzzFeed, it is going to come from that archive of messages that came through our messaging queues. So that gives us a bunch of flexibility, right? It means that your data is generally available in real time, and it is generally available for all time. We have a very open approach to data. There's no contention, right? If I want to run a Spark job on an S3 bucket and you want to do the same thing, doesn't matter. Like, we don't impact each other's performance. And it adds a second thing that is going to become important in a second, which is that you collect everything, we over-collect, we store it forever, disk is cheap, and it lets us change our minds, right? So maybe we like really don't care about Bing search right now, and so we just collapse it into other, but as long as we store that, we can change our minds and be like, hey, actually, there are some interesting usage patterns there, like let me break that out. And because you have access to that archive for all time, you don't have to worry about versioning. You can do that. So this is all sort of like thinking about flexibility and resiliency to a landscape that might change, right? And so this is where we end up after like about a year's worth of work. Right? Like, we have our Pixie Dust API, which is collecting stuff. It's going into streams, QR or key readers, which generally are like little bits of Python. Dashboards, maybe you persist that in a database, dashboards read out of it, and then there's our happy cloud of truth. So after about a year, we're like in a super good place. Our foundations are laid, we're like, great, let's turn our attention to tooling. And then the world changes. What happens in like mid-2015? Well, lots of things. Basically, video happens. And it happens for a number of reasons. The first reason it happens is Facebook changes its algorithm to strongly prefer video. BuzzFeed.com, all of its listicles had been like, you go consume on someone else's platform, but to like actually interact, like read the article, you have to come back to BuzzFeed.com, right? So we were posting and advertising basically on different platforms, but all of the content consumption was happening on BuzzFeed.com. But now, there's video. that's a very different usage pattern. People consume that on someone else's platform, on Facebook, on YouTube. BuzzFeed also itself has a bunch of new platforms. We have a bunch of apps. We invented an app for an Apple Watch. We were like experimenting, it's cool. And then Snapchat happened. So these are all things that have like very much changed how we think about content. And like BuzzFeed maybe had like a tiny bit of an existential crisis because like if you have different content types and different usage patterns, like is share still relevant? Like how do we know we're connecting with people if we don't have our share? So while our content creators were sort of thinking about that along with our data scientists, data engineering nailed it. It's cool. So for us, no fundamental changes to our data infrastructure. We can accommodate a new producer. Like you just start collecting stats from Facebook. For us, it's just the same as if you had gotten it from BuzzFeed.com, and then any apps or something or new dashboards you build to display that stuff, just another consumer. But just to reassure you guys, BuzzFeed came out of that transition just fine. We did stuff like Tasty, which is cooking videos, and ended up being like one of the most liked BuzzFeed, one of the most liked Facebook pages and web series, and we treated it the way we always do, which is, hey, things are different. Let's spin up a small team that's tasked with understanding that platform and test and learn. And what do you need to test and learn? Data. So we have the ability to collect that data and have really short learning cycles so that we can do stuff by like figuring out that people really like to watch and share food videos on Facebook. And share, yes, share is still relevant. They might be sharing it in a slightly different way, like tagging someone in a comment being like, oh my God, let's make this delicious apple pie. So we've come through this like giant bit of change, right? We've built some like foundational infrastructure that turns out to handle change pretty well. BuzzFeed.com has gone through incredible like change as a business and what people are how people consume content. And so let's think about some of the things that like I think we did well to like help enable that. One thing we do is we have like really simple systems. So each bet, it's like I can draw like a couple of little pieces on a piece of on a like little grid paper because our system is that simple. There are lots of pieces. If I drew out all of them, the boxes would be too small to read, but they're really simple. But there are only there are many services, but there are only a few patterns there, and we found patterns that work. And these patterns work in part because it gives us something to iterate on. Because so let's start with the first one. For real-time systems, you use NSQ, our queuing system, to consume a stream with a queue reader. And that queue reader is usually a couple hundred lines of Python at most. So we can do stuff that makes stuff easier. Maybe like data discovery, what streams are available is something that needs to be improved. We can fix that. Queue readers, maybe it still requires too much configuration. We're gonna fix that. And these are things that like we're actively working on. Because at this point, we're also doing something, our audience internally has changed. The tech team is much larger. We're like a 100-person tech team plus 10 or 20 data scientists all over the company, and they're building their own stuff. And they may not know, or be as interested in kind of, or build things really in the same way that I, as an infrastructure engineer, would build things. EMR and Spark is our pattern for batch and offline computation. So EMR is elastic MapReduce. So basically you spin up, it's on-demand Hadoop and Spark clusters. And then we write Spark scripts in PySpark. So our ecosystem is very much Python and Go. And so that's something we can continue to iterate on. And then for offline exploration, we have, so maybe you're a business analyst or a data scientist who's just kind of like learning the shape of the data. We have, unstructured data available in data warehouses, basically. So you're supporting the 3 different common usage patterns, and we sort of think about them as abstract products. And this is helping us be independent as an organization because we can start to abstract the ops bits away and give you monitoring for free and stuff, all the stuff that you don't want to have to worry about, and it's my job to worry about. So like, I want to be able to give you a small tool that where the only like stuff you have to write is what's critical and different for your job. Which means also thinking about in a large organization where lots of people are like building, like you build your little app and I build my app and you build an app. We may not talk that much. So I may not like hear that, oh, this took me 2 or 3 days because this like config that you, like the way you configure this service makes no sense to me. So like we have to be really aggressive about tracking down people bottlenecks, right? Like understanding what our stakeholders need. And a part of this is data science. Like they're one of our biggest partners. So understanding how they think about like what they want to build next, we talk constantly. And I think that's been the thing that has, with all of this tech we've built, there were some things that didn't work so well. Like, building our data warehouse probably took lots of iterations, but moving from Redshift to BigQuery has gone much smoother because we talk a lot more than we had before. And I think that's like the biggest thing is like we're building systems that are small and composable, but where we go next is very much driven by understanding where the people we're working with together are going and thinking. Like, what's BuzzFeed's next big questions? Our data scientists understand that super well. So that's one thing we're going to we've found is like foundational to having a good relationship between data science and engineering. So more on these like composable services. They're just lots of bits of small code that makes a tasty composition. And so through all of this, we've made our data ecosystem a little bit more robust. So now we have a time series database in addition to Redshift, which is our data warehouse. Like things are getting more complex. The ecosystem has evolved. And the way all of these things fit together is they're intentionally decoupled, right? So that we can experiment and build new things while keeping the old stuff running. Because remember, this is like, it's free to add a new consumer. So if I want to have like a dashboard and I want to have V2, or if I'm trying to do some sort of exploratory analysis, I can just spin that up as a tiny service. And I get to take advantage of what everyone's built before me, right? So like, if one team is getting there first and building, say like Instagram collections, right? And they publish their results. They may have zero idea about what other teams are using that data for. They have their own use, I'm sure. But they don't have to care about what everyone else is doing with their data. Basically, everything that is published is available all the time. Like you don't have to like revise an API to get access to because you need a new field or something. It's just all available all the time. So there's like so I promised you to talk a little bit about how data science and data engineering works together. And all of this, I promise you, comes together in a second. Because we have gotten our data scientists to write production code. And they're not writing the full pipelines. They're leveraging what other people have done before them. And this is an example, right? So this actually happened while I was on vacation, so I have zero involvement here, and no one else from data engineering did either, which it warms my heart. It means that like data scientists are empowered to do stuff that they're interested in, to experiment, and to do that without having to write a ticket and have a bunch of like back and forth with the data engineering team. They can just go and move fast and build the tools that they need for themselves. And I don't, for my part, have to worry about, oh, I'm not sure this is scalable. It doesn't matter. It just, this is one service that leverages what other people have built. So what this does is, it's a simple like sanity check for app data. And we were already collecting app statistics for a number of reasons, in part because it tells you how a post is doing. And they were interested to see split outs by versions. So they did is they said, okay, let me write a little script that listens to the stream and compares that to GA, and then will like alert me on Slack through their like very nice clean interface with their if there's something wrong. And it's a very small little script, quick to develop, quick to release, and it's been super helpful. And it's like it's caught some issues, and certainly like it's nice to know stuff like that can exist, right? And this goes to something else that I think is foundational. So we talked about supporting experimentation, supporting flexibility within your business, and really like enabling other people to like build independently. And I think that's really like what data scientists want as much as anything, right? Like to be able to do and focus on experimentation and asking new questions, not necessarily like building pipelines or negotiating with a data engineer. And I certainly don't want to do that either. So I think this is like, a partnership that works super well. And that's where, so stuff like this is what we want to see more of. And towards the end of this, we start to, so we've gone like quite far, but we're definitely not done. Things we're thinking about moving forward are providing stronger guarantees about the quality of data when you're interacting with streams, redundancy and multi-tenancy. So like completely abstracted, like it doesn't matter if you're fetching data from like US East and Amazon, US West, or Google Cloud, and to have that just be kind of seamless. So yeah, these are all, again, sort of like making stuff so that you don't have to think about where it's running or how it's running. You just only need to think about the logic of what you're building. So thanks so much. It's totally rad. We're hiring, and reach out to me on Twitter if you're interested. Thanks. Bye.
Any questions?
Thanks for that talk. One of my questions was about your layered approach to these connected services. How do you, what happens if you want to make a change or eliminate one of the services that's lower in the stack? How do you avoid this problem of like creeping dependencies that you don't even know about coming in from higher up?
Yeah, that's a great question. for some of the like collection layers, you need to be like very cautious about that. You know, like I don't think that we're gonna like completely, we wouldn't just like turn off like a collection script without talking to anybody because you understand. But for stuff that's like more in the middle, I think there's like the ideal there is not to depend on a derived stream that you don't control. So like if you are like reading from another team's thing that they're processing, so maybe like I'm emitting a stat that is that's like an aggregate. You know, that's not something that I would recommend. Like it's just much better to, and if you're gonna do that, like definitely tell somebody.
I've found in building systems that the most important decision is what my message looks like or what my fundamental unit of data looks like. Can you say something about what you guys did to architect your underlying data unit?
Yeah, so thanks for that question. So the question is, how do we determine like our fundamental data unit? And I think that's something that we decided early on to sort of punt on because we didn't have a good idea. Like stuff that comes from Facebook is very different from stuff that's coming from our owned and operated platforms. And like, it's really, it's JSON, right? And that's one thing that we're at the level of maturity now where we understand our business a bit better and are looking at schemas to like really support many different message types, but to have a little bit more clarity around, you know, what to expect. So like right now it's very much like they're fundamental to like all of our systems is like a buzz ID or some unique identifier, but the additional metadata varies like a ton by platform.
Hey, so we have some similar infrastructure at our organization. Though there are we have situations with data scientists and production systems where they're sharing resources and someone breaks something. So with our column or store, we don't use Redshift, we would use Vertica, and you know, someone like maybe me or one of my colleagues will run a massive query which will nearly take our column or store down. Or we'll have situations with our queuing system where we underconsume a queue and you know, we get into issues. So what measures do you take to prevent against this, and like what kind of monitoring do you do to like inform people, you know, something has gone wrong?
Yeah, I think there's like shared resources are a definite issue. So for the queue thing, I'll address that first because it's definitely like a risk, especially if you're developing something experimental. You know, you may not have thought about the volume it's consuming just yet. And there are two ways we address that. One is we have really tight monitoring around queue depth. So when something gets backed up, we know immediately. We have warnings in Nagios. We have Datadog instrumentation, so you can see like where the latency is coming from. And NSQ has a feature of ephemeral channels, which is specifically for this kind of use case where you can set a max depth, and when it doesn't fit in memory anymore, it just starts throwing messages away, which is basically what you want, is just like not to bother about it while you're developing something new. And then for the other stuff, we isolate. So we wouldn't have someone running expensive queries on a production database.
Hi, I may have heard it wrong, but you mentioned you moved from Redshift to BigQuery. What went into that decision, and what are the pros and cons of each?
Yeah, so Redshift was great. We still use both. So I think the usage patterns are different. So Redshift is a far more managed solution than BigQuery is. So it's nice because it like loads very easily from S3, and we've built some infrastructure around that. We use Looker on top of it for a lot of our like business intelligence. But for data scientists, we really had a contention issue. Like queries took a long time to, you have to think a lot about how your distribution keys work and how your tables are set up. And data scientists, for their part, have to think a lot about how optimal their queries are. And all of that goes away in BigQuery. Like, you just pay a little bit more money, and that's a trade-off we're like very happy to do.
Hi. Any plans to move to Kafka from NSQ, or any thoughts on that? You know, NSQ versus Kafka.
Yeah, so we've like looked into Kafka a little bit. NSQ has far less configuration. It's just very simple, and that simplicity has like worked very nicely for us. So there's no plans to move.
So to maintain flexibility, do you have to have like metadata stored to be like, oh, you know, from this state you can find this data in the other database, but after it has its own field, like how do you help the engineers and scientists navigate the data?
Yeah, so I think that's a good question. Like I said, it's all in one sort of stream. So you publish to a topic. So all of the app data gets published to a topic called apps, and you can publish to multiple topics. So some of that is like understanding the like you just see that change in the data, and I think there's and for most of the fields that's for like our core fields, those things exist, right? So like I said, we over-collect. So generally, like, one, you know where to look, which is the stream archive. Like, just look at the messages. And two, you're able to, even if we're not like storing that in some like more structured database, you're able to generate that from like the data itself, from the raw events.
So you mentioned that there's a little bit of latency going from NSQ into your source of truth, and that queries are supposed to come from your source of truth. So have you thought much about if you wanted to query some sort of a real-time metric that maybe it hasn't made it into your source of truth yet? Or?
Yeah, so all of our systems, like the dashboards I was pointing to, are like dual layer systems. There's a real-time component, which is like, so most of the stuff we're doing is counting or ranking, and Redis is very good at that. So we have queue readers that are keeping track of real-time metrics, and then batch jobs that come behind later and true up based on this source of truth. And then write those to either a persistent data store or into another place in S3 for, processing later.
Hey, I just want to ask sort of a follow-up on that, which is, so if you implement a new sort of aggregation as a queue and then you want to have your new logic applied to old data, what are your approaches to that? Do you sort of implement it twice batch as batch and as queue reading, or?
Yeah, I think it depends on where you're gonna like put that data eventually. So we actually do this quite a lot. So sometimes we'll want to reprocess a bunch of data, and in which case we just do that in a batch job and then store it in a persistent place. For something that's like, I can't think of an application, but if you wanted to do that in real time, like you might want to like replay messages, but generally like in that world where you have an aggregation, you just do a batch process, and then like that's sort of your baseline, and everything from there gets like rebroadcast as aggregated. You sort of backfill that topic.